Okay, so in the last session, what we sort of learned is what this picture is depicting. And let me move this guy aside. But we had an EC2 host, right? We connected to that box where we copied the file from the GitHub, public GitHub. We had the Docker file. We downloaded all the requirement, whatever we needed. We went through these steps. And finally, we launched a container. And then we ran that container, right? Whatever Docker run with the port and whatnot. And we can run multiple container on the same node. Somehow we expose that, and then using Postman, we were able to do this summary, right? And we got the result. But at the end of the day, that's a lot of headache where we have to manage it, we have to maintain it. The Docker image, we have to maintain it somewhere. The Docker file, we have to maintain it somewhere. What if the underlying thing change? Like in this scenario, we are using what all things we are running? We are running NVIDIA CUDA runtime, right? So somehow, what if NVIDIA changes their CUDA Ubuntu image because there is some security issue and they need to update that image? That means you as a user of this image, you need to update your Docker file. That means you need to recreate your image and you need to redeploy your containers. If it is just one container, that's okay. Typically, you will have hundreds, not hundreds, thousands of containers running for this kind of machine learning workload. And it's just NVIDIA one example I gave you. What if the Python has some bug and Python is changed, or any other library you are using has an update and you need to make a change? So the point is the maintenance of the image becomes very tedious. Also, I think, Nishit, when you were running into challenges about some compatibility, I think the version what we have pinned, I believe in the requirement.txt, right? With certain transformer of 461 and PyTorch of 19. Torch, I believe, is beyond 1.9 now, and it is 1.11 or 13 or whatnot. That means you, correct?
It took 1.13.
1.13, right. So that means we need to keep changing our requirement txt as the PyTorch is changing. We need to, if we change that requirement txt, that means we need to redo everything, right? We need to do the Docker build. So we need to rebuild the image and we need to do a Docker run again. That means we need to restart our container. What if we have to restart the container? What does it mean?
So the app will be, there will be an outage during the restarting process.
Exactly. Also, when we do this image rebuild, it takes time, right? And it takes time of who is doing the work?
The main MLOps developers.
Okay. Somebody, right? Somebody, a human, right? Correct. So a human is doing the task, and technically we want to automate all this, right? So there might be multiple ways to do it, right? One would be using some sort of a Python code or maybe embedding Terraform into this, right? The other way, and then again, I just wanted to highlight a couple of issues here, right? One was we talked about the image maintenance, the compatibility with system. What if we want to scale from one to many, right? That means we need to launch multiple containers here, or maybe in multiple hosts, right? We need more than one Ubuntu boxes. If our system is small, like if we have T2 micro here, that means we have only one CPU and whatever 2 GB of a memory. If our model itself is taking that CPU and a memory, one model, and if we need to scale from one model, that model to two container, that means we cannot launch two container on the same host, correct? Because your CPU and memory are used. That means we need to have another EC2 machine on which we need to launch the second container, or we move from T2 micro to T2 medium or T2 large or something, where we have a more CPU and a memory, and we launch more container. That means we need to have some sort of a work done by a human, or some code has to be written to manage all this thing of a scale from one to many. And then there are many things when we are doing this thing manually, right? When we do things manually, there is always error or some sort of an error we end up having. So there are many automation tools out there, but what you could do is you build and package everything as some sort of come up with a Python SDK, or use Boto3 mechanism. Boto3 is a library, and using that Boto3 library, you write your Python code and you automate this mechanism on how to launch your container, how to deploy your container, how to maintain your container, and how to do that image maintenance, how to do upskill, upgrade from a library one to the next version of the library and whatnot. So we will take a look at some of those automation concept in the next class. But in this class, what I wanted to show is a fully managed, so sort of a nirvana state. Okay, we want to start with the nirvana state, and then we peel the onion, and then we go back to how we automate everything. So remember, in the last class, we talked about this entire machine learning model code is very small, but the rest of the things has to be done to do everything in production, right? So to do all this and many more, right? I may not be doing justice if I say all this, but there is a service in AWS called SageMaker. Have you heard of that service name?
No, I didn't have.
Me
Okay.
either.
Okay, that's fine. And if I say it's a service, it's a yes, it's a service from an official service point of view, but it's humongous. It's an ocean. You can do anything and everything related to data science in this SageMaker service, right? So remember, in the earlier here, we are talking about the configuration, the data collection, the feature extraction, the process management, the analysis tool, the resource management, the data verification, the serving, monitoring. Again, we are talking about only the ML in production, right? If we look at that cycle, once we define the scope, we want to bring the data, label the data, organize the data. We want to model, train the model, build the model, and eventually deploy it in production. So that entire life cycle of your machine learning can be done in one service, SageMaker. Okay. And there are many aspects of it, many sub-service. Each service has like a 20 other services underneath. Like ground truth is primarily used for labeling. And when we say labeling, it's to label your data. So you can label your data using any mechanism. If you have a data set and you want to label your data, you can either create a job and the system would do it for you if you have simple enough data. If you want to have a label, a human to do the work, then you can have something called labeling workforce, and you can invite a mechanical Turk army. I think we talked about mechanical Turk in one of the session, but you can invite the army of people to do this for you. There is ground truth plus, which again you request it and you build a team, and they will have access to your data, and you will have a data labeled. Or you can generate a synthetic data using many mechanism or how you can generate a synthetic data. Maybe in this scenario, we are talking about a rendering as an example or a metric report as an example. But there are many ways you can generate a synthetic data based on what your project is. That's just one ground truth. Again, I'm not going to go into the detail of each, but I'll just talk about each service one minute at a time. Notebook is, I'll tell you one word, Jupyter Notebook. Jupyter Notebook is a very standard term for any data science. And you will hear this again and again, where, and then there might be many other, here, there is one. So let me start this. In this scenario, where a notebook, once it's started, it's the place where you code everything. And using that code, you can even deploy, you build your model, you train your model, even you can deploy that model using that Jupyter Notebook. So it's an interactive Python-based tool where it allows you to visualize, even you can write your own code and visualize it right in that notebook itself. And once it is there, you can do anything and everything, right? So that's on the notebook. Processing. So we were talking about the data labeling, but as your data is labeled, sometimes you need to do an ETL processing. And I'm just talking about ETL processing as one example. There might be many other processing you can do, like a Spark or ELT, or many other mechanisms you may have from a data processing point of view or image processing point of view or whatnot. Processing would allow you to do that kind of a processing job as a part of your predefined pipeline, right? And I have few created in the recent history. Training is the heart of machine learning, and we looked at some of the algorithms. I mean, I don't have any my own algorithms. I have few training jobs and few hyperparameter jobs. But here in this scenario, I may have tuned this model a couple of weeks ago using MNIST dataset, and it's showing me that this training job completed on so and so date, and it took X amount of second, it took X amount of data, it took Y amount of a compute, and it has the full detail of my job, what it did, what kind of hyperparameter it used. If there are any other additional thing like logs or metrics I want to find out, I have access to it. Finally, when your model is trained, you need to have that model. Remember in this lab, what we did in this ML session, we downloaded this DistillBart, right? CNN file. Oh, come on. Yeah. So we downloaded this model. And we downloaded the tokenizer and the vocabulary as well as a part of that, right? When we did this summarization.py. All it did was went to the Hugging Face, downloaded that image, the model for us. In this scenario, I have built this model, right? I'm training this model. That means I own this model. Okay, I may have trained it using some public data set, but I own this model and it's in my S3 bucket. And that model is with me now. So if I need to use that model to do the prediction, what we did here, right? I downloaded it from the Hugging Face. In this scenario, I need to download it from the S3 and load it to some server somewhere. Okay, that is the only difference. Are you with me here so far?
Yeah.
Yeah.
Okay. So that's the training. And finally, I'll come to inference, and then there are many others which we will look at in the future sessions. But inference is where I wanted to show you something. So we started with this model when we did the exercise last Tuesday. Was inference. What we did was an inference. We downloaded the model, right? In this scenario, this model, summarization model. We deployed that model and we ran that model as a Docker container, and using Postman or some tools or browser, We invoke that model, and that model is working the summarization, right? So to make it further, instead of doing all these things manually, what I did on that day, what I'm going to show you is one simple Jupyter notebook. Again, it's publicly available. I'll share the link in afterwards on the Slack, but I'll show you here. I have something called endpoints. And in this scenario, I created what I call the GPT-2 model. So remember GPT-2, GPT-3 conversation we had a couple of weeks ago, or no?
Yeah.
What is
Yeah.
GPT-3? I mean,
I mean,
again,
you
I
said
don't
it
need the
was
full
the,
form, but yeah, what it is used for?
I mean, like general purpose storage, no?
No, you are putting me on a shame. I'm not looking for a full form, okay? I'm looking for what GPT-2 or GPT-3 model does.
So I think it was for the naturalization, I mean NLP,
Okay,
natural language processing.
processing.
Yeah, and it actually converts the human voice into text, uh, something like that.
Okay, okay, okay. All right. I think you are getting closer. At least you are on the right track compared to Salman. Sorry, Salman, you are on a wrong track. But again, it's confusing because in AWS there is a storage called GP2. That is storage. Okay, that is a general
Okay.
purpose storage.
Yeah.
That is GP2.
Yeah,
And
I was
again, yeah, yeah,
confused
yeah.
between those two.
Correct, correct, correct. No, 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 no. It was a good wake up call. But when we say again, it's all closely related. It's a brother sister in a way from a naming point of view. But GPT-2 is what you see in Gmail, right? Gmail. I'm sure you are typing an email or responding an email or whatnot, right? Have you seen Google doing some auto suggestion?
Yeah.
Yeah.
If not, you should try to write or respond one email, right? You must be getting a lot of emails for this Black Friday event. Just reply to that email and then see what all thing Google does for you, okay? But yeah, I'm sure you would have experienced. But typically when Google, or in this case Gmail, is showing you that auto suggestion, it's most likely GPT-2 model is behind the scene giving you that suggestion. Okay.
Okay.
So it's generating text for you, right? You did not ask, but it's generating that text for you. Okay, I'll go on a limb here. GPT-2. GPT-2 is it again generative. I'll go by Wikipedia. I don't trust Wikipedia, but I'll still go by Wikipedia because this is correct. Generative pre-trained transformer. Again, the 2 is just the version of which OpenAI created, and then they created GPT-3, which is even higher. But GPT-2 was the transformer-based model they trained using 1.5 billion parameter. I don't know whether they say it anywhere here or not, but yeah, it's here. 1.5 billion parameter. And I want you to do some homework over the weekend, right? Is this some of the history of GPT-2 and GPT-3 is very interesting. So I want you to do some reading on GPT-2 and GPT-3, at least GPT-3, and question yourself when people say 175 billion parameter, what exactly they mean by 175 billion parameter? right? Or when they say they trained using X million of or X trillion of tokens, what does it mean by those tokens, right? If you want to really, again, this is not expected in MLOps, right? In MLOps, you are expected to deploy, but there are so many things happening around us in machine learning, and you are in the heart of it. Why not understand what exactly it is, right? So I want you to ask you that you should dive deep in terms of what exactly that 175 billion parameters are, or what is the token, or what is this, where is my terminal? Here it is. What is that vocab, right? Why they need a vocab or why they need a tokenizer to train this language model. If you understand, it might take half an hour, 45 minutes at best for you to understand that, okay? But I want you to understand some of this. Then you will understand the language model like anything, okay? Nobody will question you why you are talking about GPT-2 or GPT-3 or even Facebook trained 1 trillion parameter model. I mean, OpenAI trained 175 billion, but Facebook says, okay, no. We are the biggest company, right? So we are going to train with 1 trillion parameter. But why? And again, I don't want to give you that answer, because for that you need to dive deeper a little bit, so that if you understand, and then we can answer you next week when you come back. And if you don't understand what it was, I'm more than happy to guide you, and why, and what are those weights and what are those biases and how that parameters got calculated. But I want you to do some research on it. Fair?
Yeah, sure.
Yeah,
Okay.
sounds good.
So I know I digress, but GPT-2 is a 1.5 billion parameter, right? It's a language model. It's not a computer vision model. It's a language model. That means it's using text. And it was, I mean, when they created, it was 1.5 billion parameter back in those days. And there are many versions of GPT-2 available nowadays, open source included. So what I have done is, I'll show you in a second, is I have this notebook, and this is the interface of a notebook. I mean, this is inside SageMaker Studio, and there are many, and probably I'll do an entire session on what SageMaker is, deep dive. But think of this as a your IDE, right? Like PyCharm or Visual Studio or whatnot. Similarly, data science is use this kind of a notebook to do their day-to-day work, and it's using Python as a kernel, right? You see Python 3 here on my mouse.
Yeah.
Okay. And it's running on some server. So it has a 2 vCPU and a 4 GB of a memory. Okay. Behind the scene, it's EC2. Okay. But we don't worry about what that EC2 is and how it gets launched. But what I'm going to do is and I'll let you do it as well, exercise in a week or two. But first, I wanted to at least show you what this is. So this is a exercise or other notebook, which is explaining how to host a pre-trained model on a SageMaker. So remember, we hosted one model, a summarization model, on EC2 using Docker container. Similarly, it's installing, and I hope this text is big enough, or should I make it bigger?
No, it's fine. We can see.
Yeah.
Okay.
Visible.
I zoomed in a little bit more. But yeah, so all we need to pay attention is to the cells. So what you see here is the markdown, the context. Okay, this is a text which, again, you can edit this text as well. It's a markdown, nothing but a markdown, right? And it converted that markdown. So let me, if I execute that markdown, it will show me the output of that markdown. But all it's doing is a Python code. So remember, Nishit, you were doing the pip install for transformer and whatnot, right?
Yeah.
It's doing exactly that, pip install transformer. with some version, and it's installing the SageMaker SDK and some of the other things, right? So, and here is that model and the tokenizer which we downloaded. Remember from for the summarizer.
Yeah.
If I bring in this line,
There were two.
yep, we had the Distilbart CNN, right? The tokenizer and the model.
Yeah.
Similarly, but in this scenario, I'm using a model called GPT-2. The reason I am saying GPT-2 because I wanted to show you something else, right? We did summarizer or summarization last week or Tuesday. I wanted to do a GPT-2 this week so that you grasp more, you understand more, okay? It's similar code, what we see here in that summarization file, right? Where you do a model.save, tokenizer.save, here model.save, tokenizer.save, right? And it's saving your vocab file, it's saving your model and merges your txt. Next is your inference code. So remember we had our own Python file on how to, when the model get invoked, what to do, right? That app.py file. This is our app.py file, right? This is the API getting invoked and when model is receiving the data, what to do, right? So this is the exact same code for inference. Again, I have already executed, so that's why we are seeing it. And finally, what it does, it's packaging the model. So remember we did the Docker build and whatnot. In this scenario, that model which was created, so when we saved that model in the earlier lines here, right? In this line, we saved the model and that model got saved here. I'll show you here. There is model.tar.gz and the PyTorch model and the merges and the vocab and the config.json, right? Similarly, what we saw in our summarizer model, what it's doing in this case, SageMaker, is it's taking the tar file and doing its magic and creating that model as a package. And finally, it's deploying that model. And again, it's a SageMaker magic. Again, I won't go into the detail of what all does behind the scene, but once we execute this 6 line of code, all right, technically it's a 1, 2, 3, 4 line of code. This is like a extended line, right? But once we do this 4 line of code, that model is ready to do the invocation. And when I say invocation here is we are prompting this model that working with SageMaker makes machine learning, and the model is generating the future text that working with SageMaker makes machine learning and a lot easier than it used to be, right? So this is the generated text. So this is when we were doing like this call, right? Via Postman, this is equivalent to that Boto3 call. And I'll show you, we don't need to. So in the real life, if you are deploying, I'll go it one more time. I know I went through very quickly, but if you have a model or if you have that model artifact ready, you deploy your minimum requirement. One is your transformer and the other is your SageMaker library. Then you bring in your model from wherever it is. In this scenario, it's in the Hugging Face hub. So it's downloading from the Hugging Face hub and it's saving it in this folder, right? And then we have this inference code which we wrote on how to treat this model when the data comes, what to do, how to do the prediction. It's a simple Python code to do that prediction, right? All it's doing is take the model path, take the model and return the text generation pipeline, which is a function within that model using the model and the tokenizer, what it receives, right? And we will receive that result at the end. So that's a simple code. And all it does is it takes the model create a package, deploy that package on our behalf, right? It does behind the scene. So I'll show you where all those things happen. When it's deploying, it's creating that container for us. It's creating the GUnicorn server with us. It's creating the web server for us. And it's maintaining and monitoring and everything for us. And it's showing here. So it shows up as an endpoint here. And I gave the name, where is my Jupyter Lab? Here. We gave the name GPT2. So that's how it's coming out as a GPT2 as a name. Let me do this. I'll do everything from scratch. Okay. With me so far, any question? I'm going to read on everything.
Yeah, no questions.
Yeah.
Okay. So the way to run in Jupyter Notebook is each cell is like a code. Okay. So you write a code in this cell. If you start with this pound, then it's a markdown, right? And you either do a shift enter and that will execute that cell, or there is a play button here. So wherever your cursor is, it will execute that cell. Okay. And there are ways where you can do everything, right? Run and selected cell and go further, or run all and whatnot, right? Or run all markdown cells and whatnot. And there are, or if you want to run everything, run all cells. But I'll go step at a time. So I'll execute one more. So here it's trying to install the transformer, and it's saying, okay, something already exists. It's fine. Let's move on. Next one, it's gonna, or supposed to be downloading, but this model already has downloaded. So it might say that, okay, I don't need to download anything. And when it's asterisk here, right? If you see the asterisk here next to this cell, that means this cell is being executed. Okay. That is the convention.
What is the key keyword? I mean, for the individual cells execution.
Shift,
What is the
shift, shift and enter together.
Okay. It's just for the one cell, right?
Yeah, just for the one cell. So if I'm on this cell and if I do a shift enter, which I just did, I'll do it in the next cell.
Okay.
But it executed now. So the number also get incremented. So here my cell number got 3 and now it's number 4, right? So I got a new vocab JSON and new merge.txt. But
Can you run like this code in the Google Colab as well?
Yeah,
Because
yes.
I've used Colab and
Correct.
it's pretty much the same.
Correct. Yeah. This is like a Colab exactly, in a way, right? But the problem with Colab is Colab, this code is customized for SageMaker, okay, and customized for AWS. So you cannot use exactly the same code in Colab, because if you see, there are many libraries which are being invoked, which are SageMaker specific, and I'll show you in a second. So let me execute this line, and so it got executed. So number 5, and when we are packaging, the packaging is fine up until this is all operating system level, right? So it's starting the file, but when it deploys, right, this is the SageMaker magic. It's taking the PyTorch model from the SageMaker, and it's also getting the right execution role from an IAM point of view. And what I'm going to do is I'm going to change this endpoint name to something funny, right? Generate my text. That is my endpoint name. Okay, the deployment, sorry, the packaging is still going on. Okay, packaging is done now. And now I'm going to execute this cell. So I'll say this play button. And now it's deploying generate my text as an endpoint name using the existing model. So if I go back here to my SageMaker endpoints, and hopefully in if my demo god is with me, Okay, it's still executing. Okay, while it's executing, let me show you what is it's doing. So it's just creating, and this is a variable. Endpoint name is a generate my text, right? So it will come up. Uh, it's taking PyTorch model with entry point of inference code.py. So remember in our Docker container, so I'll do a side-by-side comparison if I can. In Docker container, we had something called entry point. This is our command, right? The command is nothing but the entry point. When the Docker starts, what we want Docker to do, right? So in this case, we are telling this PyTorch container. So what Amazon is doing, in this case, SageMaker is doing, it's taking the container which has a PyTorch already. So they are maintaining that PyTorch container. Okay, so all the things what we are doing to build the container, they are maintaining it for us. If there is a security patch, they go and update that security patch and rebuild that image, right, on our behalf. So they take that image from what we call the ECR, Elastic Container Registry. Here we go, ECR repository. And it's instructing that, okay, inference code.py file. So if I go back to that pre-trained, where is it? Deploy pre-trained GPT2 code, inference code.py, right? Inference code.py, that is my entry point. Model data, it's in the model path. So we gave that variable up somewhere. Role is the IAM role from an AWS specific point of view. Which framework version? So that means which PyTorch version, that is 1.5. And which is Python version you need to use is Py3. And finally, it's saying that deploy this in one instance. You see here one green color, and it's saying deployed on a M5X large, right? So it created an M5.X large instance for us. We did not need to create one. It created one for us. If we say 2 here, right, and I execute it, it will create 2 instances, make same replica of the code on both instances, and it will do the load balancing for us. If we do 10, it will do it 10. And here is the instance type, M5, T3, T4, whatever that category is, right? I'm going to leave this as an M5 and leave this as 1 for a simplicity. But it's doing that behind the scene for us, and it's not even visible to us. So if I go here, this cell got executed. I don't need to execute the next cell because that is to test, and we will test outside of this. But let me go back to this guy. Here we go. Generate my text got created 3:26 UTC. This is in the UTC time, so makes sense. If I click on this, then it should show me that, okay, it's ready in service. It's type real time. I'll tell you what exactly the real time is and what is batch is and whatnot. But that's for some other time. It's still things are, we haven't even done anything. Endpoint runtime setting, current wait 1, desired wait 1. We are saying only one instance. If we had more than one, if we want to change this, we can change it from here as well, where update the wait or update the instance count, right? Or if you want to do an auto scaling, we can do the auto scaling as well. Depends on the configuration what we want, and many other things we can do. As once we send some traffic and once we have some data, we will come back here. But it's using this model name, and all traffic is going into M5 extra large instance. Okay, so far any question?
Those files, that inference file and others, did you manually create, or it was like a framework? Actually, whenever we create a project, it creates the basic structure of the files.
No. So what I did is, I'll show you. This is what I have here is a SageMaker script mode. So this is a public Git repo, right, of AWS samples, and underneath AWS SageMaker script mode. Within that, we had, I believe I got it from here only. Yeah, deploy pre-trained model. So what I did is I git clone this entire repository into my studio, right, in my Jupyter. So you see everything here. And there I have the deploy pre-trained model. And we had two options. So if I go back to this guy, deploy pre-trained model, one is BERT, the other is GPT-2. I wanted to show you GPT-2. That's why we were going with this. This Python notebook is exactly what we see in that studio. See? So it's not something I created. Okay. I wish I created this and I can take the credit, but no. and same with the code, right? That inference code.py, it's already here, right?
So how
So
did we clone the GitHub there?
so this is a studio, right? So here you can I can have a file new and I can get a terminal, right? And that will get me a terminal, and all I do is click on wherever I am, right? So I get on that host where this notebook is running, right? This Jupyter Studio notebook is running. And actually I already have a clone repo here. So I am not going to do this clone, right? But remember, I can do that other clone. Even I don't remember now. What is the
ML, I think ML.g.
Yeah, it's not ML anymore, right? I think we changed it to something else. Yeah, ML summary.
ML summary. Yeah.
Yeah. So I actually do this thing. Jupyter Lab. Instead of that, git clone ML summary. It cloned it here. So if I go to the root of this folder, I got ML summary. And I got all our files here. And I can open that steps. Here we go. That's our steps file, right?
Yeah.
And this is the Docker file, what we were working off of. Okay. So we deployed this, right? So the point was we deployed this. What happens after it? We want to monitor, we want to first test, right? Whether this is working or not. So there are many ways. One is using the Boto library, where you use the Python Boto 3 library, and you use that. So you invoke the Boto 3 client, and you invoke the SageMaker runtime from Boto, and we can prompt anything. We can say, oh, okay, today is a Black Friday. Black Friday is, and just we leave it as is, right? And I'm going to execute that cell. Okay, the answer, the Black Friday is the day of the reckoning. And the Black Friday holiday is, and there is some other thing it can generate, but it only generate up to this, because this is, remember, this is a very small model which we wanted to try it out, and it's not generating a paragraph, right? It's for generating a text, maybe a next 2 line or 2 words or 3 words. but it literally gave us a sentence. If I change this to something else, like Thanksgiving is, and I'll say execute. Thanksgiving is the most important holiday of the year, says the National Association of Holiday Makers. Okay, that helps.
Yeah. That helps.
But in real life, do you think that user who is going to generate this text is going to come to the SageMaker and run this in this way? No, right?
No. Yeah.
So that means we need to expose this model somewhere, right? Remember, we exposed that Docker container via that port 80 or 8080, and then we got this postman to do the summarization for us, right?
Yeah. It should be kind of an API anyone can consume, right?
Correct, exactly. So what happens is, so we created this model, it's deployed, right? And it has an endpoint. I mean, endpoint name is whatever it is, right? And this is the URL. But if we hit this URL, unknown operation. Why?
It must be the post operation.
Okay, fair point. But if I do this, I'll go back to my post thing, right? And if I do this, change post URL, body, raw, all we were doing is Thanksgiving is, right? We should get some answer. Missing authentication token. Why?
Yeah. Probably we might have to add the token in the headers.
Okay. So that means we need to have some sort of an authentication done, right?
Yeah.
This URL is not publicly accessible in a way. I mean, it can be. I'm not saying that it's not, but it can be. But at least in this, as is current session, it's not. That means we need to have some sort of an AWS authentication applied to that header. That means any user who is connecting to, we must ask for some sort of an authentication, right?
Yes.
So instead of having a user do that authentication all the time, what we typically do is there are, and I'll show you one more diagram here, is there are many patterns, but one pattern I have used quite often is this. A thing called, I expose it through Amazon API Gateway, which is the public facing. I send a request to the API Gateway, which is public. It sends a request to Amazon Lambda, and Lambda in turn sends it to SageMaker. I can do this API Gateway to SageMaker as well, but I like the in-between path where I have enabled Amazon Lambda in between. Again, it might be completely new to both of you what this is, and that's fine. We will talk more about API Gateway, Lambda, and all other things on and how to integrate all this. I'll show you quickly what it is, just for the sake of it, right? So Lambda is a serverless mechanism. It's like a 20-line code I have here. This is the Lambda code I have. It's taking an input from my API gateway. So whatever API gateway is sending, it's taking that input and it's invoking that endpoint. So if you see this code and this code, no change. SM invoke endpoint, runtime, which is my runtime is SageMaker, SM invoke endpoint, right? And whatever the endpoint name is, I'm configuring that endpoint in my Lambda code in the configuration. but it's a 20 line of even these are this import code, but 7 line of Python code. And I'll show you the API gateway setup. I created API gateway, generate text, for example, and it's a post request. And all I did is integration of that request with my Lambda function, whatever that name of the Lambda function, and I'm done. After doing this 3 things stitching together, I hope this is the one. Yeah, this is the one. So this is my API gateway URL, whatever, OPJY. Again, it's not a custom domain mapping. Whatever I have this, I'll show you. Stages, test. Yeah, so this is my invoke URL, OPJY1BU, right? And I'm taking that as is, OPJY1BU /test/generate text. That was my setup. And I'm saying maybe we do Russia. No, we'll do Thanksgiving, right? Thanksgiving, send this. We should get a similar result, what we saw in the studio lab, right? Thanksgiving is a time of celebration for all of us. It's a time of celebration. Again, this is like a public data model. So we can get a random result, no doubt. Let's try Black Friday. Black Friday, I'm going to be honest, I'm not, it's giving some random text. Actually, it considered Black Friday as an April 15th. I don't know why. Maybe it was a stock market Black Friday. Okay. Any other prompt we want to give?
Christmas.
Christmas, okay. It's a great time to be part of community. Okay, not bad. Okay, Diwali is, okay, it doesn't have the data. Or it doesn't know what Diwali is, okay? Hanukkah, let's see, is it the right spelling of Hanukkah? Okay, it doesn't know what Hanukkah is. So you get the gist, right? What is it and how this model is working, at least from a raw function point of view. I know I went through this API gateway and a Lambda very quickly, but this is just to show you that I'm hitting this API gateway. That API gateway is, if I go back to this diagram, I'm the postman, right? I'm hitting this API gateway. API gateway is in turn going to the Lambda, and Lambda is in turn invoking my SageMaker endpoint, and SageMaker is responding back with the result which my postman is showing. Now, in this entire thing, all we did was executed maybe 15 or 20 line of code, and in many of this scenario, all we did is primarily packaging this model. If we have the code, this inference.py, which somebody created or you created for that matter, all we need to do is package that model and deploy that model, and we are done, right? So technically 7 line of a code. So 3 line here, 3 line here, 6 line of code, and you are done, and you are giving up all this heavy lifting to SageMaker. So we are not invoking this generate my text, we are invoking GPT2. So if it has any, oh, there we go. It does have some utilization, right? So we can see all the CPU utilization metrics, the memory disk utilization and whatnot. Now, if we need to do this for Docker, we need its own system, because Docker has its own mechanism to do that monitoring and whatnot. Also, all the logs are getting captured of the invocation into CloudWatch, which is AWS's logging system. And there we go. It's pinging That is the checking the health check. But today is what, 20? Yeah. So this should be very recent. Yeah, 3:43. So this is our response, right? This is the request, and this is the response. So let me open up the request. This is the request generated and backend response. Come on, go. Backend response. So it's logging everything. It's also logging the ping of monitoring data, and we can see that in the access log itself. If we are managing on our own Docker, then we need to stitch all this together. We somehow need to monitor and send this information to whichever the Docker system monitoring is doing. And if you want to change from one instance to two instance, all we do is do and update it, and it will do its magic. And when we have more load, it will increase the load. If we want to set up the auto scaling, it will do that auto scaling and whatnot, right? And you think that, okay, you want to clone this, simply clone this, change whatever parameter you want to change for your model endpoint, and create another endpoint, and so forth. So I know I talked a lot in last 45 minutes, 1 hour about this entire thing, but what questions I can answer in a relatively short time?
So my question is like, as a MLOps developer or the machine learning expert, right? Do we need to create those models, everything from the scratch, or is it like actually everything is available in the GitHub and we can reuse them?
So it depends on company to company, right? There are companies who are training from scratch. There are companies who are what I call do a transfer learning, right? And then fine tune. So what we did here in this scenario is we literally took as is, right? We did not do any fine tuning. But if I go back to this, my training example, where I had this training job, for example, this Lightning DDP with MNIST dataset. In this scenario, I had used, and maybe if I have a notebook, I can show you. Probably not. Yeah, here. Yeah, this was the Lightning. So in this scenario, this is the notebook where I'm actually training my model using a public data set. And I'm adding on top of my own data. And then I'm building a model. And once my model is ready, so here you go. This is my entire model training. So when we say estimator.fit, it's doing the actual model training, right? It's saying training in progress. So it's running the model, teaching the model, and then finally, whatever the iterations or accuracy I would have asked during that run, it's completing that. And finally, hopefully, come on, no, it's a lot of lines. So I'm gonna do. So I think I was going by the accuracy, model accuracy was one of the parameter. And come on, show me the end. Okay, I'll scroll. So it's done. And finally, I want to do is some sort of a, if I did not do this step, but I needed to do some sort of tuning from a job point of view. But finally here, my number of epochs were completed, and I saved that model, and that model got saved here, right? That status was completed, and I can create my model package, and I can use that model package to, where is that line? Here. So here, this is the model package creation line, right? So I can do this in the same notebook, or once my model is saved, I can do it from here. And eventually I can use this 6 line to deploy this model. So going back to your question, whether everything is available, yes, everything is available in a way, but it's garbage in, garbage out, right? Like we saw in this example, it doesn't know this is the public model. It doesn't know what Hanukkah is, or maybe my spelling is wrong, but at least it doesn't know what Diwali is. And it's at least not giving us the right answer of what we are looking for, right? So how do I train this model, this exact model, to know what Diwali is, right? So that means that is the job of a data scientist. So the data scientist, if I'm the data scientist, I would go here, rather not here. I would go here where I was training, because it's a training job. And again, depends on the type of a data, depends on the type of a model. I would load a new data with whatever the optimization I need to do in the data. And I would use the data and I would call a fine tuning job, right? So when I say fine tuning job is I'm doing a transfer learning. So whatever this model has learned, the public model, I'm using that model as is, whatever. Again, I'm not at the right screen here, but whatever that public model is, I'm using that public model and I'm teaching it what Diwali is. And then I'm training that. When I say teaching, I'm reiterating, maybe by doing 100 iteration, or maybe 200 iteration, or 300 iteration. And then I'm saving that model and I'm testing it again. And then I'm asking again that what is Diwali? And if it still gives me the garbage answer, I go back, change the data, or change the hyperparameter, either of those two most of the time. And then I deploy that model and I try again. So again, that is all functionality or typical role of a data science or data scientist. Sometimes ML engineer do get involved in many of this. And when we talk about ML ops, is primarily its deployment, not the training, right? Training is the function of a data scientist, but the deployment is the function of an ML ops engineer. So packaging the model, deploying the model, monitoring the model, testing that model, and building that entire life cycle is the function of ML engineer / ML ops. Does that help?
Yeah, so the ML engineer creates all those building steps, and they might share it with data scientist, only the model part, right? And after that, they will improvise the model based on the testing and training scenarios.
Correct. Most of the time, and again, it varies from company to company, right? But most of the time, the data scientist is responsible for training the model, making sure that the model is accurate enough where it knows what it's supposed to be doing. And once that model is trained, the number of iteration what it's supposed to be doing, it complete, it tests against the data. So typically what happens is if I'm a data scientist, I would split my data into two batch. One is called training batch, the other is called testing batch. And training batch is where I train my model, and testing batch is where I test my model. Right? And I know we haven't gone into the training portion of it, but that is how it happens. And I will go through one of the example where we train a model and we test the model. And before we train and test, we will split the data from that existing data set, and we will test that whether our model is predicting it correctly or not. Okay. I went straight into deployment because it's once you understand deployment, then it's very easy to peel back the onion, and then we can go back of what exactly happened behind the scene, right?
Okay, got it.
So what do you want to do for homework?
I mean, you only said like we have to go through the GPT-2 and GPT-3 and have a look at the parameters, something.
That's 1 hour at best. Oh, but Salman, you still have homework from Tuesday to complete. Okay, I see.
Yeah,
I think
I'll
Nishit, you will have trouble as well, right? So you will need to go through again.
I'll be trying with EC2 this time because of the space issues that I'm facing in my local environment. But right now I have idea like how to do that, so it will be easier this time.
So here is what I want you to do as a homework, right? I'll give you this link of the public GitHub repo where it was, wherever that AWS samples, right? I want you to go through one of this notebook, at least go through it. And maybe here we looked at the GPT-2. Maybe you want to go through BERT. And I want you to come and brief me what it's doing. Can you do that?
Yeah, sure.
Yeah.
Okay. So today what we learned how to deploy using SageMaker, right?
Yeah,
we go back to that lab.
The
Correct.
flow from the postman to the API.
Correct. So if we go from here to begin with, how to host a pre-trained model. In this scenario, this model is already, we are downloading from the Hugging Face Hub, right? GPT-2 model. We downloaded that. This is an inference script. Again, somebody had created. We did not, but we launched that, and using that script, we packaged our model. Our model is packaged now. Then we deployed that model using, again, it's deployed using container. Okay, so container is the way to go. Even if you are doing it manually or you are doing it in a SageMaker, it's always a container. So we created a deployment mechanism. We gave an endpoint name, generate my text in this scenario, right? And simple 2-line. It's doing its magic. It's deploying that on an M5X large instance, and we said only one. We can change from one to many. And once it deployed, we tested out some prediction like Thanksgiving or Black Friday or whatnot. And if we go back to the model, what we deployed in the model, sorry, not in the model, in the endpoints, we created this generate my text, and we saw it got deployed. It's in service. We tested, instead of generate my text, we tested GPT-2 because we deployed it for the endpoint. And we saw some CPU and memory utilization. And now we see the CPU utilization got dropped now, right? Because we were trying a few minutes ago and that got dropped. That entire model deployment pattern was something like this. We have the M5X large. We expose it to Lambda. So this is a simple 20-line Lambda code using the same mechanism, invoke endpoint. We expose that Lambda to our API gateway. This was the URL we started off with. So the postman is hitting the API gateway, which in turns goes to the Lambda Python code, which in turns invoke the SageMaker parameter. We invoked, we asked what Thanksgiving is. It gives us the answer, but it doesn't know what Diwali is, right? So that is how we learn end to end from how to make our life easier, not to do everything manual and let SageMaker do heavy lifting for inference. Okay, thank you very much. With that, I'll talk to all of you next time.